Hey, what up, guys? So, going over the parent function transformation classwork problems. And while doing this, I'm going to reteach the lesson for those who might have been absent before break. Maybe they want to see it one more time. Maybe they just didn't get it the first time. Maybe they weren't paying attention. I can just kind of go over, the whole thing one more time. So, in order to do that, we're going to start with just the first two questions, and we're going to go over them because the first two questions are only the visual and English aspect of these problems. So basically, they have the least amount of actual math involved. So we're going to start with those, and then we're going to use those to bridge into the remaining questions. So here we go. Let's start them off. So it says, describe the transformations necessary to transform the graph of f of x, the solid line here, into that of g of x, the dashed line. So all we have to do is figure out, how do I turn this graph here that's pointing to the right and turn it into the graph here that's pointing to the left? And what I just said there is actually the beginning of the question. We're immediately pointing to the right here on the original, and we're pointing to the left on the new one. When you flip like that, it is called a reflection over the y-axis, also called a horizontal or a left and right reflection. So it's a reflection over the y-axis. In addition, we are moved up 1 unit. Oftentimes, you can use the word translate or shift. I'm going to use the word shift because it's shorter. So shift up 1 unit. This is the entire question. You simply have to use the correct language. The word is reflection when you're flipping it around, and shift up 1 unit. It's very important to understand this process and to do it. So we've done it twice, but we're actually going to be repeating that process multiple different times in these questions. Here's our answer to number 1. Let's check out number 2. Number 2 has a very similar idea. Hopefully you notice that the graph is pointing up for the solid line, and it's pointing down for the dotted line. So now that's another reflection, but this time it's a reflection over the x-axis. So this is a reflection over the x-axis. Instead of pointing up, now we're pointing down. In addition, that little V solid point was in the center, but it's been moved over to the left 2 units. So we'd say shift left 2 units. And again, you could use the word translate or move instead of reflection if you really wanted to use flip. I'm just trying to use the words that are most likely to show up in your future courses. So hopefully those are easy enough. However, the remainder of the questions will start going into the quote-unquote real math or the algebra, or the parts that aren't the English and the visual. Because they don't have that, we need a little bit extra in terms of a lesson. So we're going to go a quick little mini lesson. If you don't want the mini lesson, you want to go right into the answers and stuff like that, you can skip ahead a couple minutes. And yeah, but here we go. We're going to do this little mini lesson. In order to do the mini lesson, we're going to go ahead and look at this function I have here. This is a function that's more difficult to graph and deal with than what we're going to be doing for quite a while. Technically, we're actually going to learn how to do questions very similar to this, later in the year. Actually, if I made this a 3 here, this would actually be one that would be similar to what you're doing later, but it goes too high up off of Desmos, so I don't really want to do this question with a 3. I'm just going to do it with just a 1. But we'll actually learn how to graph this by hand later in the year. But for now, the point that I'm trying to make is that there's going to be the original function. We're going to use f for original. We're going to use g for the second. And g is going to be transformed by these 4 letters, A, B, C, and D. So those 4 letters, what's going on there? We have those things, and they're going to be doing different ideas. Let's visually watch what happens as we look at these different letters. So first of all, I'm going to change this to a 0 before I do anything, and change this to a 0. And I'm going to turn this graph on. The red one's going to disappear. Okay, so now it's blue. Okay, now we're going to go ahead and change some of these values, and we're going to see what happens. So if I make a larger number, if you notice, the blue one is changing. So make it bigger, get bigger. So it changes. It's actually being stretched apart is the word we use. On the other hand, and we can actually, if I did this, I don't want to do that. No, I want to change the numbers here. If I change the numbers from 1 to 5 and make this a 0.1, we can actually just hit play. And we can watch it get stretched out and then come back together. So it's being pulled apart vertically. We call this a vertical stretch. However, if instead we were going from, say, 0.1 up to 1, now, as we get smaller, closer to 0, this a value getting smaller, we might be able to see that instead this blue guy is flattening out. So it kind of gets pushed together. We call that a compression. Okay. In the event that a becomes a negative number, let's go ahead and change this to a negative number, a -1. I kind of want to change this like this, -5 to -1. Step is 0.12, but again, I don't want to flip it just yet. If it's a -1, if we notice, the red line here is our original, and the -1, is the upside down version of it. We again have that reflection. So let's go ahead and change this back to a +1. How do I change this again? A +5 to 5. Okay, we're going to change this back to a +1. Okay, now it's back to original. On the flip side, with B, let's do the same thing with B. If B becomes bigger, we notice it actually compresses horizontally. And if B gets smaller, it gets pulled apart. It's called that stretch. And if B goes negative, it flips, instead of flipping up and down, it flips left and right instead. So that's kind of what's going on. When you make this a negative, it flips left and right. You make this a negative here, it flips up and down. Not too big a deal. Big A's stretch it apart, small A's compress together. Big A's push it together from side to side, and small B's there will pull it apart. Let's see what happens with C. If I move this to the right, oh, the graph goes left. So if you notice, C does the opposite of what you think, and actually the same thing happens with B. As I make B a bigger number, it squishes it. It makes it smaller. So we'll notice that with B and C, it does the opposite of what you're thinking right away. And again, if I move it left, it goes right. With the letter D, if I go move to the right here, it goes up. When D is a positive number, it goes up and down. It goes left, it goes down there. So this is like a visual to see what's happening. And if you'd like a version of notes for it, I have a version of notes here. I'm going to have to make my face go away. How do I make my face go away? Like turn my webcam off. That did not work. How to turn my webcam off here? Transition. Oh, there you go. There's my webcam gone. So this guy right here, if you wanted to use it, you can definitely feel free. It's basically a set of notes that goes over every single thing. And I'll do my best to come back to this over the course of the lesson. But the point is that we talk about A and B, how it makes it bigger and how it stretches. And when it's a negative A, it flex up and down. A negative B is left and right. C and D, translation, or left and right shift. And to make a long story short, if you can take notes on these guys and be able to refer to them over and over and over again, it really will make the remainder of our questions a lot easier. So I'm going to go ahead and then hit the transition back here. All right, we are back at it again. My face is back. And okay. Anyways, so if you want to use that, feel free. If you don't want to use it, you don't need to. I'm going to do my best to refer to it quite a lot. It's particularly actually up here is very, very useful for quite a few of these functions, just to see where those letters A, B, and C are. Let's check it out. Number 3. So we're going to have to write g of x in terms of f of x, the dashed line. So we have our dash line there. How do we do these questions? We have to figure out first the English. So we're going to start with the English just like we did in the last question, but it's not the final answer. So I'm going to do my final answer in that same blue color that I've been doing. We're going to go purple for the questions before. So we're going to call that a reflection. Oh my. Over the x-axis, because instead of pointing up, now we're pointing down. We've also moved 2 to the right. So shift 2 right. However, because this is the math portion, now we have to go back, and this is where you kind of use your notes. You got to figure out where the reflection over the x-axis comes into play. So the reflection over the x-axis, just to bring it back up, reflecting over the x-axis is right here. It's whenever you have that negative a, is when you reflect over that x-axis. So we know right away that this means that a is a negative number. Specifically, it's going to be a -1. So that will be part of the final answer. So a is -1, or just a negative sign. And likewise, again, we could look at our notes for it. I'm just going to go ahead and write it out. But shifting 2 units right, turns out that that makes that C has to be equal to a -2. Be careful with it. C does the opposite of what you think, just like that letter B. All right, so for our final answer, it wants us to literally write it just like that. Again, in the notes, it wants us to look like this up here. We only have A and C in the question, so we don't need to include B and D, but A is a -1 and C is a -2. That's how our final answer is going to look. We're going to write g of x equals negative, we could write -1 if you wanted to, x minus 2. And there you go. So inside of the parentheses moves you moves you to the right, left and right. Same idea here. We're going to do this one a little bit faster. So we're going to go ahead and figure out what happened here. So this coordinate was right here at the bottom, and now it's over here. So we've moved right 1 and up 2. So we'd say this is a shift right 1 and shift up 2. A shift right 1, we just had a shift right. So this is going to be our letter C again. So this is going to be C is equal to -1. And the shifting up and down, turns out that is the letter D, is a +2. And on the outside, C and D are at the edges there. So what's our answer going to be? It's going to be g of x is equal to f of x minus 1 for the C and +2 for that letter D. So in the event that you're not understanding what's going on, we really got to make sure that we are kind of connecting the dots with these notes, because I'm doing it quite fast, but the first times that you do it, you really need to take your time. So let's talk about this one more time. We talked about the shifting right 1 and the shifting up 2. That part's easy enough. The visual can't really help too much if you can't see it moving to the right 1 and up 2. But what do we do after that? After that, we have to figure out where is a shift right 1. So we go to our notes, and like, where does it say shift? Where is the shift? Okay, translation or shift, so it's got to be C or D. And moving graph right, -C moves the graph right. So that's where our -1 comes into play. I guess you can't see it because of my face again, but hopefully you have these somewhere else on the side, or you took a picture from earlier. Yeah, anyways. And then, again, that letter D moves the graph up and down. Oh, no, actually, I wonder if you couldn't see the answers before. No, you could. You were fine there. So there's a D, and the C and the D go here on the edges. So once you figure out what they were, you just kind of rewrite it without the B and the A. Because you don't have to write that, don't have to write that. We have the -1 for the C, the +2 for the D. Got to keep on trying these no matter what. Even if we're not quite getting it, got to keep on trying. Here we go. Describing the transformation. So here, it's the same exact idea as actually problems numbers 1 and 2, where you just have to use the English, but instead of having a picture, you have the algebra. So you got to figure out which letters are which. And this is where that top of the notes comes into play. So we see this square root function here. So when you have that square root function, looking at this guy. So here's our square root function. We got to figure out, okay, A is on the outside, D is on the outside, B and C are in the inside. What is this going to look like? Looks like A out here, D out there. Okay, so A and D don't get affected. So it turns out that B is -1. And C is also going to be a positive 1 here, right? And what does that do? So that b being a negative, using those notes again, that's a reflect over the y-axis. And this guy right here is a shift right. Oh, I lied to you. It's a shift left. Why did I say right? It's a shift left 1 unit. It does the opposite of what you think, so be careful. Same concept here. We want to look at where this absolute value is. So we're going to take a glance at those notes here, and we have these absolute values here. We have the A on the outside there, B on the inside, C on the inside, D on the outside. So taking a look at it here, it looks like we have the outside negative sign. So this is going to be A is a -1, and then here on the inside, C is a -2. So this is going to be a reflect over the x-axis. And this guy right here is going to be move or shift, sorry. Shift. This is going to be to the right 2 units. And there you go. We just got to keep at it. We're going to keep on trying it. We're not going to give up on these. Here we go on to number 7. Okay. So on number 7, yet again, we got to figure out which letters are which and which ones are being affected. So we're going to take a look at our notes here. So we have A on the top, B and C on the bottom, D on the far outside there. So it looks like we have the subtractions. So that means this is a C and this is our D. So we have C is a -2 and D is a -2. And that means that we are going to be moving shift right 2 units, and this is going to be shift down 2 units. Same idea with number 8. We again want to look at our notes really quick. Which ones do we have? We have something that deals with x squared here. We got that A on the far outside, B and C on the inside of parentheses, D on the outside. But because there's no parentheses in this question, we kind of know right away it's got to be the A and the D. So A is going to be 2, and D is going to be -3. We don't often deal with these dilations, but this is going to be a vertical stretch. Vertical stretch by factor of 2. Yeah, you deal with the stretches and the compressions more so when you get to pre-calculus. We're only going to be barely touching on them just to introduce them this year, but we do a lot more of the reflections and the translations this year. And this one's going to be moved down or shift down 3 units. All right. So numbers 9 and 10, I'm going to explain using what I call the visual method. Numbers 11, 12 are explained using the numeric method. Both methods are completely valid, and I actually recommend learning both of them so that you have a full understanding of what's going on. But when it comes to the test, you may pick your favorite as to which one makes more sense to you. However, in order to sketch the graph of each function, you need the other version of the notes in front of you. I actually don't have them open right now. I'm going to go ahead and pause recording and get them open. All right, we're back at it again. So here are the notes that we had. We had like the transformation vocabulary, and then right after that we had the mother functions notes. And really what we have to do is we have to know what these pictures look like. So we have these pictures here, you know, the x squared idea, the x cubed, the radical, the absolute value, these straight lines. We have all these ideas, and we're going to be using these throughout this kind of worksheet and what we're doing. Kind of need to know what these pictures look like. I personally recommend eventually memorizing these, but for now we can definitely just use our notes to look at them. So I'm going to keep this open, but the point is we have this quadratic here, is x squared, and that is what our first question looks like. It looks like this x squared. That is to say, we see that we have a squared in the question, and because we see we have a squared in the question, that must mean that the original function was f of x equals x squared, which has a version of the graph looking like this. So that's kind of like the original graph. And now we have to combine all the things that we've learned so far. We have to figure out what letters these two are, and then we actually have to use those letters to move this graph and create our picture. So if you go through the entire process and you look at your notes and you figure out what's going on, it means that C right here is a -1, D is a -1. This is a shift to the right 1 unit, and this is a shift down 1 unit. So you need to take this picture and graph it, shift it to the right 1 and down 1, and that's what we're going to do. So on here, the way I like typically doing my graphs on these blank white pieces of paper, on the actual test, I'll probably give you a grid or give you an option to use either, because I can print the grids on the test. That's really not a problem. So I'm just going to go ahead and put a couple of them down. I'm going to do up to 5. Don't forget, in class, you can always ask me for graph paper. I'll give you graph paper that you can do these on if you'd rather do them on graph paper. But you're taking the original graph there and you're shifting it right 1 unit and down 1 unit. So I'm going to draw the answer in purple. So it starts down here. There's right 1 and down 1. And then you kind of just have to look at the original graph and kind of figure out where it's going to go. And it ends up looking kind of like this. So you took the original graph and you moved it right 1 and down 1. It is just a sketch, so you actually don't need the grid version if you don't really want it. Here we go. Same exact process for number 10. So the first thing to do is recognize what it is. We have that cube right there. So f of x is going to be equal to x cubed. That's the parent function or the mother function. And if you look at your notes, you see the original graph kind of looks like this cute little S looking thing. Kind of like that. Maybe a little bit more flat in the middle here. Maybe not as curvy in the center, a little more flat. Maybe it is more curvy. I don't know. Whatever. Point is that it's a little bit different. But we got to figure out what these letters are. So figuring out the letters, this guy in front out here is, this is A. So A is -1. And that 3 there, we have C is -3. That's going to go ahead and reflect over the X. And this is going to be shift right 3 units. So for our actual graph here, let's do it. We got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so the original graph kind of goes dead through the center, but here it's got to go shifted to the right 3 units. So we know it's got to start shifting over here. And then the S kind of goes the other direction because it's flipping over the x-axis. So instead of going up here, it goes down here. And instead of going, down here, it goes up over here. Like that. Yours is probably going to be prettier than mine. I mean, we could kind of see what it really looks like on Desmos. If we actually wanted to check it, you can actually just type these into Desmos. I mean, that'd be cheating. But you can't do that on a test. So let's see. Let's do it blank Desmos. Blank Desmos, we just type in g of x equals -x minus 3 to the 3rd power, and we kind of see exactly what it looks like. So you see what I mean? It's a little bit more flat right there and then curvy afterwards. So mine's like not too bad, it's kind of close, but that's kind of what we're looking for. All right, so I said on numbers 9 and 10, I was going to do them in that visual and English way, but you can actually avoid all of that stuff. And instead, you can simply use the notes one more time to do the problem in a completely numerical way. So typically, some students will end up like doing it this way because it feels more like drawing in English, and some students will end up liking it on this number 11 and 12 way because it feels more like math. You're doing all these numbers and stuff. However, I do recommend that you actually learn how to do it in both ways. I do think it's useful to do it both ways. So let's check out this number 11, how you would do it using the math way. So you start off in exactly the same point. You begin by noting what the original function was, which in this case would be the square root of x, or the radical of x. You don't need to draw the picture, the little mini picture. You're not going to need it this time. A is going to be equal to -1, and C is going to be equal to +3. However, what makes it as a different start, instead of starting off by writing down the cute little mini picture, you start off instead by copying the table from the notes. So where does this table come from? Let's talk about it really quick. So the table in question in your notes says this. It says 0, 0, and then a 1, 1, and a 4, 2, and a 9, 3. Like, Mr. Richards, how'd you memorize that? It's not like I really memorized it. These are just square roots. Like, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. That's what this original function is. After that, let's check out what our notes say, because we haven't looked at our notes in a bit here. Let's look at what the notes say here. So the notes say that A and B are always multiplication or division, and C and D are always addition or subtraction. Furthermore, the A and the D, which affected the up and down values, affect the Y values. And the B and the C, the inside these parentheses here, these affect the left or right, or the X values. So this letter A here, that's a multiply, and it's a multiply the Y values. Specifically, what that basically says is, it says multiply Y by -1. Multiply Y by -1. So you're going to take all those values there, and you're going to multiply them by -1. And this guy right here is addition or subtraction, but C does the opposite of what you think. So this is subtract 3. Subtract 3 from x's. And that's all you do to create your little table of values. So we're going to create our table of values. We have x, and we got g of x. And so we're taking all those values, and we're going to subtract 3. So 0 minus 3 is -3. 1 minus 3 is -2. 4 minus 3, +1. 9 minus 3 is 6. So again, you're going from here to here, you're subtracting 3. Over here, 0, 1, 0, 1, 2, 3. What's going on with that? Well, we have to multiply the y's by -1. So every single one of these gets multiplied by -1. That really just means make it negative, right? So 0, and then -1, -2, -3. Finally, we need to create our cute little XY chart. So we have 1, 2, 3, 4, 5. Let's go out to 6. And then we have 1, 2, 3, 4, 5. Don't need any of the negatives, actually, did we? And then we just play connect the dots. That's all we have to do. So -3, 0. -3, 0 is right there. -2, -1 is right there. 1, -2 is right there. 6, -3 be right there. And trying to make it curvy when you connect. And there you go. There's our graph. But again, you could have, if you wanted to, done the other method. Say, hey, there's your reflection. There's your moving left 3 units. So you take the original picture that you know what it is, and you flip it upside down. You move it left to right. It's just another option. Let's repeat that process on number 12, just so you can see the entire thing. I'm going to do this one at a picked up pace. So we're looking at here, and we say we got f of x is equal to 1 over x. That's our original function. We can figure out that a is equal to -1, and that c is equal to -3. So yet again, we're going to be multiplying by -1, but actually adding 3 to the x's. So on our original chart, I actually don't know what I gave you guys for that original chart. I wonder what I gave you guys. I bet you I gave you like a half, a -1/2. That's probably what I did. Let's look at what I gave you guys. I want to make sure I copy the same ones. Here's our exponential. Yeah, 2.5, -1, and 1. Yeah, those are the numbers I gave you. All right. Let's do it. So let's say we had 2 If you have a plug in 2 to the original, you get a half. Plug in a half into it, you get 2. 0 is undefined, so we actually don't need to write anything for 0. And then we got 1 and 1. We got -1, -1. Those 4 coordinates should be enough. So if we went to x and g of x, the concept is we are taking the y values and all the y's get multiplied by a -1. So you end up with -1/2, -2, -1, +1, and all the x values get added by 3. Be careful. It's the opposite of what you think. So that x here becomes a 5. This x there, we gotta add 3, right? 3.5. I'm gonna be lazy and do a mixed number. You can write 7/2 or 3.5 if that makes more sense to you. So 3.5. So 7/2 equals 3.5. I don't know. All right. And again, we're adding 3. So we're going to add 3. We're going to get 4. Add 3. We're going to get 2. And then you just play, connect the dots. So we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And we have 5, comma, -1/2. So that's going to be like right here. And then we have 3.5, comma, -2. Should be like right there. And then we got 4, comma, -1. That'd be like right there. And then we also have 2, comma, 1. That would be right here. You do have to kind of know what the original graph looked like. So just going back to it. This is kind of what the original graph looked like. Kind of with a whoosh here and a whoosh there. So we're looking for those whooshes. If you notice the whoosh kind of goes right there, kind of like this. And this one, if you follow the whoosh, it ends up looking like this guy here. And again, these are rough sketches. They don't need to be perfect. I really do think the visual method would have been easier on this one instead of the number, but I wanted to show you that, it exists and it's an option. So anyways, there you have it. And we'll learn a better way of doing it. We actually learn what the word is here when it kind of points up and down like that. It's called an asymptote. We're gonna learn more about it later. Let's go on to number 13. All right. So number 13, identify the parent function and write in a given equation. So this one, now we're going back to kind of the easy mode by comparison to what we just had to do. So a lot easier. Let's check out what I mean by a lot easier on this one. So identifying the parent function, the first thing you have to do is you got to think to yourself, which one of those 9 functions that we wrote down looks like this S? So if we look at it, we're going to go back into our pictures here. We have to figure out, hey, which one looks like an S? Well, this one kind of looks like an S. That one looks like an S. So which one is it? Well, the problem in question, it kind of looks like it points more up or down. So that means our original function, f of x, is going to be equal to x cubed. Then we have to describe the transformations. How is it different? So the original function, x cubed, just to draw a little mini picture so we can have it off to the side, looks like this. If you notice, it points the wrong way. So it's a reflection. This is a very special type of function where the reflection over the x and the y are actually the exact same thing. Let's see what I mean on Desmos really quick. I'm going to look at the original here of x to the 3rd power. And if I put f of x equals, I'm only use a and b because I only need a and b. It's not adding sliders for me. Where are my sliders? Oh, because it's defined by itself. There we go. There's my sliders. Okay, so what I was trying to say is if I make a negative number, it flips it, vertically up and down. But if I make b a negative number, it flips it left and right. It does the same exact thing. There's no difference. In fact, if I make them both negative, they flip back on top of each other. And that's the point that I'm trying to make, is if you flip it over upside down, this guy would point up and this guy would point down. But if I flip it left and right, well, now this guy's pointing up over here and this guy's pointing down over there. It does the same thing. So you just have to pick a letter, A or B, and I prefer to use the letter A because it's kind of out in front, easier to deal with than the parentheses. So reflection over the x-axis. Also, if you notice the S here kind of goes through the dead center, but this S here goes to the value 3, so that means it's shift up 3 units. A reflection over the x-axis, this guy right here, means that we have A is equal to a -1. A shift up 3 units means the letter D is equal to +3. And if we're looking at... Oof. Oh my gosh, I gotta sneeze and then it just doesn't come. It's the worst feeling ever. It's so annoying. I'm sure I'm gonna sneeze in like a minute or two, and you know, what are you gonna do? All right, so to write our final answer, g of x equals A is the guy out in front, so that's a negative right away. We don't have the letter B, we don't have the letter C, so we don't need any parentheses. X cubed, and then after that, +3 at the end. And there's our final answer. Let's check out number 14. So number 14, same exact idea. We first have to identify the parent function. Look at our notes, which one of them has this frowny face or happy face looking thing, and it turns out the original one is f of x equals x squared. It also has a reflection over the x-axis, so it's a reflection over the x-axis. And it's also been shifted right 2 units. So we have the reflective reaction shifted right 2 units. What does this mean? This means that this A over here, this guy is A is -1, shifted right 2 units, mean that C is going to be -2. Be careful with your answers there. To write our final answer, g of x equals, that negative is out in front. C in the question, when B and C are in the question, you need parentheses. So x -2, and then a squared. Cool beans. Number 15. Number 15, answer key is correct technically in the back of the book. However, I'm going to ignore it. If you'd like to talk to me about why the answer key is correct and what it is, that's fine. However, for my class on questions like this, where I'm asking you to take a picture and go somewhere with the picture, I'm specifically going to say no dilations. No dilations for Mr. Richards. Because you deal with it more. Oh my gosh, I can't even read that. Anyways, no dilations. Point is, I'm not going to deal with dilations in my class for these pictures. We're going to save that for pre-calculus. If you would like to talk to me one-on-one about how you could have identified that there was a dilation, we can talk about it. Just let me know one-on-one. I'll kind of show you how you could have done it. However, ultimately, it is more effort. And we're just going to save that for pre-calculus. We're not going to do it this year. All right, so... the picture there, what are we going to do? So first of all, you have to notice that our original function, our original f of x here, I'm going to do this down here. We're going to say our original f of x is going to be the square root of x, that radical idea. In addition, it has been moved left 1 and up 2. So left 1 and up 2. So that means that we have C is equal to +1, be careful. D is equal to +2. And writing our final answer, we got g of x is going to be square root of x plus 1 and then a +2. Dope. Number 16, continuing on. By the way, I'm going to remind you, if you've just been copying these answers, try on your own before you actually do the question. Seriously, pause the video. Take some time, attempt the question on your own. You will have to do these on your own for the test. So let's see if we can figure something out. Go for it. So hopefully you paused the video and did all the work. But here we go. We have f of x is going to be equal to x squared. There's our happy face. We also noticed that we were here and we went left 2 and down 3. So we got left 2, down 3. So that's going to go ahead and be C is going to be equal to +2. Be careful. And down 3, D is equal to -3. Final answer, G of x is going to be equal to, remember whenever you have C, you need parentheses. Parenthesis, x plus 2 squared minus 3. There we go. Let's do it. We're moving on to number 17. We are almost done, guys. We only got 4 left. Power through, transform, and write the resulting function as an equation. So now we just got to figure out what these letters are and do it. So this guy says write 1 down 3. So this is going to be C is equal to -1. Be careful. D is equal to -3. Write the answer. F of x equals, and we got the square root of x minus 1 minus 3. That's g of x. Whoops. That's a g. It's a beautiful g. Most beautiful g. All right, cool. G of x is that -1 minus 3, because it's translated right, is letter D. And letter C, sorry, and translate up and down is the letter D. Reflect across the x-axis for this one. So reflecting across the x, that means that a is equal to -1. And translating up 2 units, if you translate up 2 units, that kind of means that D is equal to +2. So rewriting it, we got G of x. A is on that outside, negative x. There's no B and C, no parentheses needed, and then D on the outside. Okay. Number 19, expand vertically by a factor of 2. Vertical by a factor of 2 means that A is equal to 2. And translate up 3 units means that D is equal to +3. We got G of x is equal to that value A. There's no B and C. We don't need parentheses. 2x cubed plus 3. Boom. Compress vertically by a factor of 3. This guy, you got to be careful. If you're doing this by a factor of 3, it works the way opposite of what you think. So you got to put a 1/3 for that value of B there. Translate up 3 units. D is equal to 3. F of x, that's got G of x. G of x, we got to be equal to parentheses 1/3 x squared plus 3. And you might say, hey, could I have written 1/9 x squared plus 3? You definitely could have. Does that mean to compress vertically by a factor of 3 is the same thing as expand? It's vertical, not horizontal. What am I doing? Mr. Richards cut from the team in the last part of the question. So D is still equal to 3. You're still correct there. But if you're compressing vertically, you're shrinking it together. So that means that the letter A is equal to 1/3 because you're compressing it. My bad. My bad. Here's our G of x. 1/3 x squared plus 3. Man, oh man, Mr. Richards not doing what you're supposed to do at the end there, but I blame the fact that it's a 42-minute video. Have a great rest of your day, guys. Enjoy. Peace out. And thanks for getting your homework done. Have a good one.